Hello, everyone. Uh, I- Let me share my screen and just wait a second. Yeah. Hello, everyone. Good day, good afternoon, and good night. Thank you, everyone, to join this hackathon. Now, I want to share something about writing Ethereum WebAssembly with Sewup. I'm a Rust engineer in Parastate, also second state. My name is Antonio, and here's my GitHub. You can, if you have problem on this framework or a problem on the hackathon, you can contact with me via GitHub. So, what is Sewup? Sewup is a Rust project. It's an open source at GitHub, and it tries to help developer build developing contract, just like a normal web backend. And this framework utilize Ethereum WebAssembly. Yep. So why we want to do this? Because there are something beneficial, and we can benefit from Rust. Rust is a safe performance language. Also, if we want to build something WebAssembly, Rust is can build a really small size binary WebAssembly because there's no runtime and it can still got small size, safe, and performance. So Rust is a good language for building WebAssembly. And then, what is Ethereum WebAssembly? For short, is EWASM. Uh, what is EWASM? EWASM is it try to redesign the Ethereum smart contract execution layer. And now we can talk about the relation between EWASM and the WASM. WASM is a format. It is a format of executable on the website on the web. Browser can execute the WebAssembly, and Ethereum WebAssembly is something subset of WebAssembly because Ethereum WebAssembly provide some special API such as Ethereum Finish or something like that. But the whole format is based on the WebAssembly because they give some restriction on the WebAssembly, so it's kind of subset of WebAssembly. So what is a contract in the web? That's a problem. If we know this problem, and we will know why we will need EWASM. Yeah. Yeah, contract is the application layer of Web3. Just look. Let me look at the right side. Right hand side. The right hand side, you can see this is traditional web. It's a Web2 server, and once we want to interact with a Web2 server, we want to compute something or try to store something in the database through the Web2 server. We need to interact with the API. This is traditional web mechanism. Yeah, the API layer is can be writing really huge of program such as Rust, Python, JavaScript, or Ruby on Rails, or almost anything. Every language can write it on this, and people use client such as browser or Chrome or any other things can interact with this API, and this API will help consumer, help user to put their data on the web server. And in the blockchain is somehow Web3, a next generation web or privacy network. We also have some application layer. Here we have application, and client and people also need to put data in the on-chain, and also want to do some computation on the data or get some information on the data on-chain. They also have something application layer, just like API or something handler. Previous, we use EVM, and now we also have EWASM. There's a slight different because EVM is language restriction. So not every language can use the EVM, but if we use EWASM, the this will be a binary format, and there can be a lot of language on this. And Sewup is a project try to utilize EWASM and build use ROS to bridge here to here, and let developer easier to write blockchain applications. So what is current state contract in Rust? In year 2019, November 27th, there's already have EWASM Rust API here. The version is 0.11, and we can write Rust code and compile into a WebAssembly binary. And if we have this binary, we can put it on chain. If the chain has the EWASM executor, and everything can be run on chain. But why we need Sewup? If we just use the EWASM Rust API, and we try to write some very classical and classical contract, we use this to write a ERC20 contract. We will see a lot of things is beyond the domain of a web developer. You can see there's something even a Rust programmer will not like this, because there are some functions that don't have return type. It's not really clear. And you can see it was an API revert. Actually, the program, if once the program goes here, then it will be returned. So this return is not really clear. It's not like the Rust behavior. And also there are a lot of low-level operation on the bytes level, such as this. We can cut some data from the input data. So there's a gap. If we take a look on the Rust program, Rust framework on Web 2, such as Rocky. This is a Rocky code. You can see that this is the main function. Rocky uses a macro or something like the character. Just launch the Rocky and mount all of the handler on the root. Yeah, you can see there's mount the hello handler, and the hello handler will use this macro. It will describe this function will be a get function, and also the URI is hello, name, age is a path. If we interact with this this Web 2 application, it's just very easy to use a browser. We type in hello and then age, and it will return hello and how old are me, and return back as a string. So it's really easier to develop a Web 2 application in Rust. But so far we can see that if we want to use Rust in the application layer to build a contract for Ethereum, it will a lot of obstacle, and that's really pain. So here's a pain point. We can see the EWASM Rust API is not really Rusty API, because a Rust API should return result and option or something like that. Make developer clear to know something is successful or something is fail, or know there is something not or there is none. And the operation level is too low level. Most of operation is based on byte 32. It's a bytes by bytes level development. For most of web developer in current stage, they don't care. They do not care about the string or do not care about the bytes. They only care about the business and the application layer. So there is a gap here. And also the routing is a problem. We can see that if we use Rocky in Web2, routing is really easy. We just use get and a URI here, and everything will be okay. It can be routed. But in blockchain, we use functional signature to route the request to the handler. But there's no good macro or good helper to handle on this, and there is no test environment for the blockchain application, because most of application or ROS project are use cargo test for test their program, and in blockchain we all need to deploy the chain on the testnet or deploy things on local testnet or global testnet. There were a lot of trivial work to get the currency, even there is not valuable, and also there will be a lot of network issue. So let's read more detail in the EWAS and Rust API. You can see there are something like code result here. It will function code and get a code result. And this is Rust syntax, but not in Rust style. If something in Rust style, it will become a right-hand part. You can see a code function and you will get the result, and result will have two parts. One part is a successful, and another part is something like code error. And error can be different kind of list. So even both of these is Rust code, but the right-hand side is really Rust style, and help developer to avoid problem and good handle their code. So that's the reason and the pain point. So we launched the Sewup project and help people to build a better blockchain application on the blockchain world. So that's Sewup. This is a summary. In Web2, we also have business level web application. In Web3, we have blockchain application. Yeah, and by level in Web2, we have something like Hyper. Hyper is the Rust crate or Rust framework, help you to handle the request or response in bytes and bytes, by bytes or bytes in the string level. And we have Rocky or with other Active Web or Nico or something. There are a bunch of framework to help people to build a web application in Rust. But in Web3, we have EWAS and Rust API. As I mentioned before, it will become stable in year 2019. But this layer is like a percent. So I'll try to bridge from the buy level to the business level and help people to easier to build their blockchain application on the blockchain world. And then how to solve this gap? First, blockchain is something really important and crucial with money. So security must be first priority. So Rust is a good meat for this purpose. Besides, we want to make things really high level development, and also want to develop experience just like Web2. So this tool is so-called contract developer as backend. We try to help developer or based on the Web2 backend developer easy to join the blockchain world and develop contract. Yeah. So the detailed goal of Sewup, we try to provide APIs, have a result, have option, and have good errors. The error type we utilize this error and anyhow the crate. This is a modern Rust framework. These two crates are used in modern Rust framework. And also we try to provide the high-level operation, and the people develop with Sewup can just like handle key value DB or handle a relational database, and also provide functional signature methods, help people easy to routing their application, routing their blockchain application go to different handler, and just like developer in the traditional backend. And then we also have provide a test environment for the developer. We use Watson Edge to build a runtime, and the runtime can automatically do the deployment and also run the test case on the runtime. So it can become really easy to test with cargo tests. And also deployment will become easier than before. If you are a developer or engineer from the traditional web, you don't have very detailed knowledge about blockchain, but you still want to build application. You just fill up a file called Sewup, and you fill up this file and run the CLI, and the Watson will be compiled and auto deploy on the chain. It will become really easier, and this experience will really like something, really like the developing experience on the traditional backend. Okay. And then we can see the errors. Errors, we use the something like these errors. Yeah, you can see this, and you can write it really in Rust way, and you can write a good error message, and you can see that. Okay. And then this can our framework can easy to use. So this is a example. Use the Sewup to build a contract, and it can be really easy, and you can use in general Rust style and modern with a modern error handling. You can see there's a return this error type, and also you can return something. If some not validated, you can return the error earlier, and also there's a return OK. It's a raw style result, and you can see this part is just matching your code. This is the main entry. It goes in and matching your the client request and to the different handler. The matching part is use the functional signature, and the handle the functional signature become really easy. You just use function sig and use the function name, and you will get the functional signature and match the handler. And also functional signature will automatic handled by the Watson function. So this developing experience will really like the traditional web. Okay. So we also do a lot of things help people to easier to build the contract in the Rust with this framework. For example, although there are some limitations in the WebAssembly, but we still can use string in this in our framework. And also we provide a row structure and row structure. The row structure is a wrapper for web byte 32, but you can easier to bring a lot of things to convert to row and also convert back. For example, you can use bytes just into a row, and also the primitive numbers and also string or size string and a lot of things. And this is an example use a key value storage. So here's a create a bucket, and bucket can storage everything, every structure you define you write by customize by yourself. For example, this is an example simple structure, and he has two field. It's a trust is a boolean field, and a description is a string field. And you can easy to put the data on this and with string and with a structure instead of structure, and save it and commit. Yeah, the data from the handler go to the chain. You don't need to worry about the byte level things. You don't not to you should not touch the something like byte 32 and slide go to slice and go to large details things, because we want to bring a developer experience just like a traditional backend web backend, and we are happy and welcome the traditional web developer backend developer to join and use our framework. So let's Sewup. And for Rusty development, we provide something easier like this. You can init a project, use cargo Sewup. It's a command line tool, just cargo Sewup in it. And also after init, you can run the cargo test, and you can see the test can be run. And if we want to deploy the contract, just use cargo Sewup. And you can check out our example. Some of example writing the client in Rust. Client, you can use traditional clients such as Web3.js or something like that. And also you can use Rust, write a client for yourself. And you can check out our example, and the client can be run in cargo run. Okay. Here's a video that see first and know more about how to init a Sewup project. You can check out this video on YouTube. Uh, yes, there's only a background music in this video. So I think it's okay if you cannot hear the video. And you can go to YouTube to check out the video. Okay. Okay, this is a short example for you to know the how to init a Sewup project. And here's a video link, and you can check out our GitHub. You can check out our GitHub. I send the link here, and you can see this hello example. You can check out this. They also have great background music on this. And then we also provide detail. We also provide a detailed description of each step. You can check out this document and know the each step and more detail on this. If you are not really clear for this, this document is made from our team member. It's really clear. So let's keep going on this. Yep. So let's go. I go through the detail on how to use the Sewup tools and generate your first Sewup project and know each part of this. If something I miss something or much detail, you can check out the link and the documentation I provide in the Zoom Zoom chat room. And also, if there are something missing on the document or also on the slide and on the video, and you can just open an issue on the GitHub. I am willing to help you to figure out your problem and solve your problem. And core is still going, still evolution and try to bridge the low level blockchain developing into high level and help you easier to build your blockchain application. So first, if you want to install a Sewup tool, you just Cargo install Cargo Sewup. You can try this. Cargo is a tool used manage the Rust project. If you have installed Rust before, you will have Cargo in your environment. Once you install the Cargo Sewup, you can use the Cargo Sewup this command, and you can just Cargo Sewup init. If you Cargo Sewup init, you will init the default type of a project. We have three types. Currently, we have three types of Sewup project. The default type, Rusty type, and auto type. The default type is something like you just can put data on chain, and the return will be much simple. It's just okay, and if something error, it will give you the error message. If a Rusty project, the return will be a object, a Rusty object. The Rusty object will be a result because every return type in Rust should be a result. It will be okay result, okay for something, or error for some error object. The Rusty project is very suitable if you use the client just with Rust. It can be really easier because the return type is a Rusty object, and your client will get the object, and you can just check it's okay or there's something error on this. But if you are not using the Rust client, maybe you can try the auto. Auto will try to auto unwrap the result. If the result is okay, we will return the instance in the result. Because other language, most of the language don't have a result protocol. So the return will not work by a result type. So if you are not using the Rust client, maybe you can use the auto. Or if you just want to put something on chain and check and just want to know it's okay or not, you can use the default type. So we encourage you to read the wiki on our project. We have wiki on our GitHub project, and you can check out that. And also you can use another parameter -p. -p can, after following is a path, you can -p to a folder, and Sewup will try to make this folder become a Sewup project. So there was something like this. There was a .cargo and a configure.is. There are something to set out some ROS flag for Watson. You don't really worry about this. It's just here. And also there's tradition in general cargo.toml. It was some all the dependency will in the cargo.toml. And there was a Sewup.toml. And this file will be getting ignored because there are some you can provide some private key and the URL link you want to for the blockchain you want to deploy, and some privacy information in this file. And also there will be a source and lib.rs because once we write contract is just like a library. We will compile this library into Watson and put it on chain. And once user want to interact these things, it just interact with your library. So it will be source and lib.rs. If you check out our example, you can see some of our have client.rs. Client.rs is ROS client, can interact with lib.rs. Okay. And then let's just dive into the part. If you init a project, use cargo Sewup init. You can see there something like this is a constructor. Constructor is something only executed once. Once you deploy your contract on the chain, the constructor will run once. It helps you to set up something, or set up some instance, set up some constants, or set up some format, maybe it's key value format, or set up a count, or set up something like that. You can write it in a constructor. And then there are something like this. This is handler. You can have different handler, just like a traditional web. People can interact with this handler. And then there's the main function. Main function, you can see this is auto type. If you can also use ROS-T type or other things. And you can write something, you need a contract, and contract get the functional signature. Use the get functional selector and match this part and get the result, something like this. And also there's test. You can easily use following macro and write a test like this. And this test will be run locally, even there's no test network, and you don't even have any test network or have network issue. You can run really easier in your environment just with cargo run. Okay, so I need to talk more detail about the contract constructor. Here, constructor do things like this. This is a KV type of contract. In traditional web, sometimes we need to create table or create bucket for the storage. There's something like that. It can easy to write these things in the constructor. For this, take this calling example, we can see it's a KV store. So there's two buckets and the bucket is key is row and value is row. And in bucket 2, key is row and value is simple structure and call bucket 2, and try to build these 2 buckets and save, and so this storage is safe. So it's something like you just create a DB or create a first table for your application. Currently there's no return value, so in Constructor is somehow not really rusty, but you can put in here, and you can do something like table schema or key value bucket or some instance here. And then handler and main. In Web 2, we use routing with URI for handlers. In Web 3, main use route for signature. So once we decorate, we'll use this macro for the function hello, use EWASM function hello. Actually, they will automatically generate a hello sig, this signature. In main function, we match the contract and match the request from the client. And once client use the EWASM, use the hello sig, you will go to the hello function. So this is really just like a traditional backend. You can check out this and to know more about how to do this. And if you don't care about this, you want to focus on a business level, you just put these things and everything will be okay. Because this functional sig is based on the functional name and input parameter, so there will not be conflict. And if you want to use something like Web3.js or something like that, because the type is different from the Solidity or other language, so the function signature will not the same. There are also a way to specific the function signature you want. You can check out the function signature for some input parameter and just put in here. Also, you can check out our Rust doc about the EWASM function. You can know more about this. Okay, and now we go to the test part. As mentioned before, we want to make tests easier, so we use EWASM test. Sorry about there's something typo here. EWASM type attribute, and help developer to build the runtime and deploy your contract on the runtime, and also test on this. So in this test case, we will add further 2 test case. Try to build your contract and also try to build your constructor and make sure everything will be okay. And if everything is okay, and the test, then this part will help you set up test runtime. And this function will put in after the contract deploy and into the test runtime. And the result you can use something like this, EWASM auto assert equal. It tries to assert the hello handler will return the hello world string. Yeah, so that's really like the thing you developing in the Web 2 and just like develop as a normal web backend. Okay, and then just quick review the hello example. Oh, sorry. Okay, can you hear me? Just want to mention that after uh, 0.1.5, we have changed. We have changed. The deployment deployment section to the Sewup.toml because this change help developer to git ignore the privacy things such as private key and public key and also the blockchain network you develop. So you can I just mentioned this. You can check a video and this part has been changed and you just need to modify the Sewup.toml, not the deployment section in cargo toml. Okay. Okay, let's back to a slide. So you can see this is hello example. Uh, this is really easy. You could just use cargo Sewup and call Sewup in your project and use write something like a string in the handler, and you can just use your Rust client just like this, and you can get the result. Deploy it on the test network. If you don't have if you have network issue to access the test network or something like that, you can use cargo test. It can be easy to test this on the local, and we will use as a Western Edge, so you can check out maybe this part. Oh, okay. Maybe you can check out this part by yourself. Okay. And now let's go to the next slide. So let's talk about the inputs. Uh, we are using Rust to build the EWASM. However, there are something inputs. There are different inputs. One of the inputs is something like from the contract developer, because the input is get sent to uh, the the library API and will be a determinate when the compare time. And also there are some input from the contract caller is a runtime input. So handle this, you can see that if we use a simple function and it called ETD. This input is a defined input. It's compile time defined. When the version builder, we always return something like ETD and never change. They also have something input is from a real user and real client. Where you can user interact with the contract. So if you want to handle this input, you can check out our Rust doc about it was an input form. It's a macro, and you can see the contract move to this is a function. This is a handler. Means the contract will move the contract, give the data input data will give to the handler, and get something like this, and the handler can get or deserialize the input the binary format and handle this. So the input will be something it can be deserialized. And just like traditional web, we will post something or put something, use the form, HTTP form. A form is an object, and form can give different data. So you need to put an object, and this object can be deserialized. It can be the input data. This concept is the same as the form in the traditional web. When you post a form from from browser to the backend, so you can easily build out your object no matter what kind of object. It just can be deserialized, and everything will be okay here. And then we talk about outputs. There are different outputs. Default output will be use this arrow, and this arrow will be some message here. If something wrong, the message will return. As mentioned before, Rusty will be return result, the Rust result, and also the you can customize arrow as you like. Because the client may not be use this arrow or anyhow, and it is easy to customize your arrow with different arrow crate. And auto is try to unwrap the result, because if you are using non-Rust client, you will need auto type. And then the output for example, this is customer arrow. The arrow is a static string. It's a Rusty type, and return arrow 0. We just put the map arrow, a function map arrow in the end. Yeah. And here's an example if we want to return a type, auto. It's just like this. We use auto, return any our result that is string. And the actual result will be a string. Okay, so if we have different, we want to auto output, but there are different type. How can we do this? Because Rust is a strong type language. This may be easier to do in some weak type languages such as Python or JavaScript. But in strong type language, we need something type we call ewas and any. You just put ewas and any in the result. And everything you want to put is okay. It can be serialized and it will be taken into ewas and any. And after the main function return, the serialized data from the ewas and any will be returned. So it can easy to return different types in different handler. Okay. So ewas and any is a wrapper for the output type. You can check out this doc. And also it can easily convert from any type or any structure you build just with a serial straight. Okay, now we go to the test part. Tests have two macros. As mentioned before, we use WebAssembly runtime and we automatically add two tests. One is compile runtime test. Another is compile constructor type test. Sorry about this. This is just typo here. And this test, following test get greeting will be run in WebAssembly. And there's a bunch of test assignment codes, such as equal, so okay, or auto is for the main function auto type, and rusty is for the main function rusty type. Yeah, and also have a by function. You just say equal and by and give a hexa string. This is a address. So we can mimic something, some different user to interact with this contract. So this is really good for you to write a contract and try to do a SEL or do some blocking for different people or different contract, different user. You can check out our example ballot. Is a voting example. You can see how we can use this and build the contract. So if you want to debug, it's really easy. You just use Sewup ewas and debug. It's a macro, and you can also can use a log file to record all the debug message. Just put the ewas and test just like this. And when you run the test, you just cargo test and dash no capture, and all the things you want to debug will just print out. It's really easy. We all know as a blockchain developer, we all know debug blockchain or debug smart contract is really painful because a message you will swallow on the chain. But if we can use cargo test on our local, so the debug message will be easy to show, just like this. So we can see which is color address. This color address is default, so we are not modify it. So it's something like that. Okay. So I check if there's something. No, okay, nobody calls me. Okay, and then you can see it's an example. You can see our default example or something like that. You can see the debug. There's a value will change from different handler. This is debug message. So deployment, as you can see in the video, is really easy. Just fill the information. But the more detail we do is that if you use cargo or build only, we will compile two things. One is a constructor WebAssembly, another is runtime WebAssembly, and we will merge this with two WebAssembly, become a deployable WebAssembly. And if you are not use a build only flag, and the deployable WebAssembly will based on the URL deployed to your blockchain network. So the first time the construct version will be executed, and then the runtime version will be stored on chain. This is a basic mechanism. If you are not a blockchain developer, you don't need to worry about this. This is already handled by Sewup. You just type go Sewup, and everything will be done. Okay. And then if we want to interact with the project, so also we can use cargo Sewup general API or general API JSON. And you can use Web3.js or something like that. You can interact with that. Okay, now that's the basic format. We just build the runtime version and try to figure out which handler is this, and build in runtime, write the Rust code to generate, and run the generator and generate the API. Okay, so following are some example I'm not covering in this talk because they are more domain specific. If you want to KV, maybe you can check out the KV example. If you want to ERC20 or other ERC 1155 or something like that, you can check out this. We already provide a lot of library and API for you and help you to build more blockchain application. And also we have RDB like APIs. So following our examples, you can check out, read the example by yourself, or maybe we will show more detail and talk more detail in next hackathon. Yeah. So this is a voting example. Also, we have voting example and more business level examples. So the last, blockchain brings the trust to the world, and Rust is the stem of the trust. So we are happy here to share how to use Rust to build the EOSN contract for Ethereum. And thank you for your listening. If you like our project, please go check out this link and open issue, do more PR, or start the project. Yeah, okay. If you are interested in our project VM, Western Edge is welcome to contribute. Here's the link of Western Edge. And now, if you have question, you can talk to me. Else, you can open issue on GitHub or anything. Okay.